Hey guys, so this is going to be a video on truth tables. Hopefully you've already done the reading and hopefully you have your book out in front of you. If that's not the case, then you should pause this video and do the reading and or get your book so that you can reference it. So we're going to move kind of quickly through these concepts since you've done the reading and since you have your book in the interest of keeping this video short for you guys. So as you read in the book, a truth table is just a little table that we use to help us evaluate arguments. Now we're not going to use it for that purpose this week. We'll do that next week. But right now we just want to get the basics and make sure that we know what's going on and we know what we're doing so that we'll be able to use this for that more complex purpose of evaluating whole arguments next week. Alright, so for now, we're just going to go over some of the logical operators and, like I said, the basics of truth tables. So here on the board, I have a bunch of claims, and most of them have logical operators. I will just do a really quick refresher. So P is just a claim. There's no logical operator. Remember, P and Q are the variables that we usually start with in logic. That's the convention. So P is standing in for a propositional claim. In the next column, we have the negation. Negation is a logical operator. It attaches to one claim, either a simple basic claim like P, or it could attach to a longer claim like P and Q. So negation, we just write with this little squiggly line. Easy. Next one is conjunction. Now your book writes conjunction with an ampersand, but that's not really the convention in logic. So in logic, when we write out a conjunction claim in logical notation, we either use a caret or just a simple dot. So I just want you guys to have some exposure to the proper logical notation. So that's what we're going to use in this video and for other videos, but just know that this means conjunction and it's the same as in your book. They use the ampersand. In a conjunction claim, the P and the Q here, these are the conjuncts. So P and Q are the conjuncts for this whole conjunction phrase. All right, so we'll move to disjunction. We read this as P or Q. And P and Q here are the disjuncts for our whole disjunction phrase. All right, lastly, we have the material conditional, which is the conditional claim, as we call it in your book. So it's a conditional claim. We read this as if P, then Q. If P, then Q. P in this claim is the antecedent and Q is the consequent. So P is the antecedent, it comes first. Q is the consequent, it comes second. If you want to remember that P comes on the left-hand side and that the antecedent is on the left side and the consequent is on the right side, that's fine. That's all you're going to see in this class. So if that's what helps you, go for it. But do remember the words antecedent and consequent. Okay, so let's go ahead and start our truth tables. Or actually, before we start the truth table, I actually want to give you some content for P and Q. So I know we talked about how we use variables to make it simpler and easier for us to evaluate the form of an argument and not get distracted by content. But when we're just learning things and just getting the basics down, sometimes it helps to have the content so that you're not abstracting away completely from what we're doing. So you have something to latch onto and help you make sense of the stuff that we're doing. So I'm going to give you some really simple claims to fill in P and Q, and we'll use those as we're going through the tables to help us understand a little bit better what's going on. Okay, so it'll be really simple. Just make P something like I like pie. I'll make Q, I like cake. Okay, great. P is I like pie, Q is I like cake. How many truth values can P have? P can have two truth values, and any claim can only have two truth values. Claims can be either true or false. There's no kind of true or like kind of false in logic, just like there's no kind of equals in math. So P can be either true or false. And how many rows are we going to need in our truth table? 2. You should know this from the book, but as we get into more complex claims with more variables, then you're going to need a way to figure out how many rows are in each truth table. So the rows in your truth table is equal to the number of truth values that you have, which is always going to be 2, so that's great. Remember, everything can be either true or false. So the number of rows is equal to the number of truth values, 2. raised to the power of the number of variables in the claim that you're evaluating. So we're evaluating one claim. The number of rows that we're going to need is 2 to the power of 1, which just equals 2. Okay, so we have 2 rows. P can be either true or false. I like pi can be either true or false. Great. So let's move on to negation. So read this as not P. What would we read this as if we're substituting in, or replacing our whole claim with the content in for P? It would be I don't like pi. So we're saying, what are the conditions under which I don't like pi is true or false? All right, what if P is true? If it's true that I like pi, then is it true or false that I don't like pi? It's false. Great. What if it's false? What if I like pi is false? Then is the claim I don't like pi true or false? Then it's true. Awesome. So negation's really easy. You take whatever claim you're evaluating, or you take whatever claim you're negating, and you just flip the truth values of that table. So we were negating P, so we just took P's truth table, we just flipped the values. Great. All right, so our next logical operator is conjunction. So we have P and Q. What has to be the case in order for the conjunction claim I like pie and I like cake to be true? Let's put this another way. Back up 1 second. So now we have 2 variables. It looks like we need more rows, right? Because the claim that we're evaluating has 2 variables. How many rows do we need? We have 2 raised to the power of the number of variables that we have, which is 2, so we're going to need 4 rows. All right, so we're just going to write true, false for P. I'm going to give Q a little space here in its own column. And we want to make sure that we have all the possible combinations of P and Q being true and false. So here, I'm going to do the first 2 rows with Q being true, and the last 2 rows Q being false. And now we have every possible combination of P and Q being true and false. We have them both being true, we have them both being false, and we have each one being true with the other being false. Okay, so now we have our 4 rows, so now we can evaluate the conjunction claim P and Q. So this is I like pie and I like cake. What has to be the case in order for this to be true? What row or rows am I going to write a T in here? We'll number these 1, 2, 3, and 4. All right, so what rows am I going to have T in? I'm only going to have T in the first row. P and Q is only true if P is true and Q is true. So I like pie and I like cake is only true if it's true that I like pie and it's true that I like cake. They both have to be the case in order for the conjunction claim to be true. And for all conjunction claims, they are only true if all of the conjuncts are true. So what about the other rows? They're all false because at least one conjunct is false. All right, so we know that it's false when at least one conjunct is false. We know that the rest of our rows are false, and this is our truth table for a simple conjunction claim. Let's move on to disjunction. So what would have to be the case in order for the disjunction claim P or Q, I like pie or I like cake, to be true or false? You have this in your books. Yeah, so we have true if both the disjuncts are true, and we have true if just one of the disjuncts is true. All right, so a disjunction is true as long as at least one of its disjuncts is true, and it's false if none of the disjuncts are true. So it's only false in that 4th row. There is something known as an exclusive or an exclusive disjunction. In that case, only one disjunct can be true. So something like the door is open or the door is closed, right? That for a claim like that, only one of the disjuncts can be true. we're not going to worry about that now. That's going to be really important if you go on and do anything with computer science, or if you go on and study logic, but we're not going to worry about it here. Your book doesn't even cover it. I wanted to make that point to you in case anyone was wondering about situations like that. It comes up a lot. I'm saying that that's a really good thought and way to go, and don't worry about it for now. We're not going to do that in this class. So we're only focusing on what's known as an inclusive or this inclusive disjunction, in which the disjunction claim can be true if all of the disjuncts are true. So the only time our disjunction claims are going to be false is if all of the disjuncts are false. All right, so the last one is the conditional claim. I'm going to read this as if P, then Q. I'll say something like, if I like pie, then I like cake. So what has to be true, what has to be false for this whole claim to be true or false? Meaning, what does this truth table look like? Well, you have it in your books, but I want to give a little bit more of an explanation about what's going on with this truth table. And hopefully it's going to make even more sense after this discussion and the next video on necessary and sufficient conditions. So in order for if P then Q to be true, what has to be the case? Well, it could be the case that both the antecedent and the consequent are true. And it could be the case that the antecedent is false and the consequent is true. But it cannot be the case that the antecedent is true and the consequent is false. So in this third row here, this one, in the third row, our conditional claim is going to be false. A conditional claim can also be true if both the antecedent and the conditional are false. So the only time a conditional claim is false is if the antecedent is true and the consequent is false. Let's think of a different example to make this make a little bit more sense, hopefully. So if we take a different conditional claim, like if it's raining then the grass is wet, and we put this in. Let's run it first, saying that both the antecedent and the consequent are true. We'll say it's true that it's raining and it's true that the grass is wet. So we know that it's true that the conditional, if it's raining then the grass is wet, is true. What about if it's not true that it's raining, but it is true that the grass is wet? What does that mean for the claim, if it's raining then the grass is wet? And think about this. We're saying, if it's raining then the grass is wet. We're now in a situation in which it's not raining, but the grass is wet. Does that have any bearing on the claim that if it was raining, then the grass would be wet? No, it doesn't. So it could be the case that it's not raining, but I spilled my soda outside and now the grass is wet. In that situation, we would have it be the case that it's false that it's raining, but it's true that the grass is wet. But it could still be the case that when it does rain, the grass does get wet. So just because the antecedent is false, the consequent is true, that doesn't mean that the whole conditional claim is false. It could still be true. What about the third row? So we'll say, I'm telling you that if it's raining, then the grass is wet. And right now, it's raining and the grass isn't wet. Hopefully, it makes sense to you that would be false. But again, if it doesn't make sense to you yet, just hang on, because we're going to have another video on this. And if you still have questions, that totally makes sense. This can be really tricky, especially as we go on, we try to apply it a little bit more. So definitely let me know if you have any questions about this. But just for this, you need to remember that when the antecedent is true and the consequent is false, the whole conditional claim is false. Okay, lastly, we'll think about it when both the antecedent and the consequent are false. Can the conditional be true? We're going to take our conditional again. If it's raining and the grass is wet. Think about the weather in North Carolina, where I live and where I'm standing right now as I'm filming this video. So currently it's not raining, and currently the grass isn't wet. So currently the antecedent and the consequent are false. If I make the claim, I'm saying if it's raining then the grass is wet. Right now it isn't raining, and right now the grass isn't wet. But the conditional claim is still true. It's still true that if it does rain, the grass will be wet. That when that happens, when it rains, that the grass gets wet. So even though they're both false, the conditional claim is still true. So again, a conditional is only false in the situation in which the antecedent is true and the consequent is false. All right, again, we're going to make a little bit more sense of this in our video on necessary and sufficient conditions. Until then, after then, or at any time, let me know if you have any questions.